In today's video, we're going to be solving systems of equation using the elimination method again, but looking at a little bit more complex problems where we just don't have to add or subtract one of the equations to the other to isolate the variable. So again, all these equations are going to be in standard form. You have x, y equals the constant. X, y equals the constant. Now, if I look at these just as they are, nothing eliminates if I add or subtract them. But there is a way I can manipulate one of the equations, because you notice what you can do with these equations is you can multiply them all by a number, all the terms in the equation by a number, so that it stays balanced, because whatever you do to one thing in an equation, you have to do it to all the terms in the equation. So if I take a look, I wrote this over here. I look at this equation, the top equation and the bottom equation. I try to see if any of the coefficients go into each other. So I notice 4 goes into 8. 5 does not go into 7. 4 goes into 8 how many times? Twice, right? So you multiply the bottom equation by 2. Now, not only do you multiply the bottom equation by 2, the first term, you have to multiply the entire thing. So when I multiply it, I get negative 8x, negative 10y. And I have to multiply also the last one, which is negative 50. And then I'm going to write this top equation right here, right? I'm going to write it right below it. So now I can add them together. So that's my new system that I'm going to solve for. So you'll notice these cancel out. Whoa, 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 whoa. These it's not being patient today. Here we go. These are going to cancel. Negative 10y plus 7y is going to be negative 3y equals, did I write that right? Oh yeah, I messed up. I should have wrote 47 down here. Good thing I made that adjustment. So this is going to be, well, it's going to be positive, first of all, positive 47. There we go, because I wanted to write that number, not what I wrote below. All right, back to our equation. So I canceled these out. Negative 10y plus 7y is negative 3y. Negative 50 times 47 is negative 3. One solve for y, so I divide both sides by negative 3, and you get y is 1. So back into my equation, we'd solve for y, got to plug that into my coordinate, so my y is 1. Now I got to solve for x. So you could plug it into this equation, or your original equation up on top. I didn't want full screen, but I'll take it. Up top, right? And that's what I'm going to do. I'm going to plug in that y equals 1 all the way in the top here. Let me zoom out. So I'm going to plug this y equals 1 all the way into the y up there. So we have 8x plus 7 times 1 is 47. Then it becomes a two-step equation that it can solve, that you all are very good at solving at by now. And you get 8x is 40. Divide both sides by 8, and you get x is 5. Okay. So the same process of what we did in the last lesson, when we're adding and subtracting equations, except the only difference is you got to multiply a number by a coefficient so that one of the terms cancel out. So this is going to be 5. Submit. Yes. New problem. That was a lot like the last one. That was a lot like the last one. Let's see. Okay. No. Here we go. 6x plus 8y equals negative 8. X plus 4y equals 4. All right. Clear this page out. I got to write my new equation. 6x plus 8y equals negative 8. And the other one is x plus 4y equals 4. I'm going to put the 1 out in front just to show that there is a 1 out in front. Now you take a look at here. Well, actually 1 goes into 6 and also 4 goes into 8. So you could eliminate either letter to start off with. I'm going to eliminate the y's. Okay. Now, in order to eliminate, you got to multiply by 2, but not just a positive 2. You remember, I want to eliminate a positive 8y, so I have to multiply it by negative 2. So when I distribute everything by a negative 2, I get negative 2x, negative 8y, and negative 8. And then I'm going to write this equation right below it, just so I have everything lined up. Then I combine them. All right. So negative 2x plus 6x is 4x. Negative 8y plus 8y cancels. Careful, negative 8 and negative 8 is not 0. It is negative 16. Divide both sides by 4, and you get x is negative 4. All right, so that means we're going to go back here. X is negative 4. All right, now I'm going to plug it in to, doesn't matter, again, it doesn't matter what equation you plug it into. I'm going to plug in the top one. Plug it in there. 6 times negative 4 plus 8y is negative 8. So you have negative 24 plus 8y is negative 8. Add 24 to both sides, and you get 8y is 16. Divide both sides by 8, and you get y is 2. So my solution is negative 4, 2. All right. So the main skill you got to know in doing these problems is what are you going to multiply one of the equations by? All right. And I'll kind of walk through maybe just starting off some of these rather than going through the whole problem, because once you get the equations lined up and figured out, then you wouldn't, it's just like the last lesson. So in this one, I take a look. 4 doesn't go into negative 7, but 2 does go into 6. 2 goes into 6 how many times? 3 times. So I would multiply this bottom equation by -3. All right, and that would eliminate the y's. If I took a look at, all right, another equation. Let's look at another equation. This one you could do either. You could multiply this one by 9, or you could multiply this one by 3 because both go into those. If I took a look, let's do this one right here. I can multiply this top equation. 2 goes into -6 3 times. I can multiply this top equation by 3. Or I can multiply this bottom equation. You notice this goes into this. I can multiply this one by 2. So there are multiple ways to do these problems. You just have to make sure you're kind of showing the steps and you're distributing. Okay, 5 goes into 15, 9 doesn't go into 10. So what I would do is I would multiply this bottom equation by -3, right? Because -3 times 5 is 15. So you kind of have to take a look at the equations, see which ones go into each other using kind of your times table skills. And doing those problems, you will eventually get to the answer. Now, in the next video, I'm going to show this is going to be the foolproof way to do any of the problems, okay? And because if you're not good with your times tables, maybe you want to use this method. It's going to take a little bit longer. It's going to require more calculations. But if you're not good with your times tables, you're going to see the other way you can solve these equations. All right. So good luck with these problems. Thank you for watching, and good